In this video, we're going to go over a review of perpendicular bisectors and angle bisectors. A perpendicular bisector of a segment is a line that's perpendicular to the segment at its midpoint. So a perpendicular bisector is going to go through this segment right at its midpoint, and we know that this is going to be, the two lines are going to be perpendicular to each other. So what we know about this is that these two segments on either side are going to be congruent to each other, and those angles are right angles. That's what a perpendicular bisector is, and that point right here in the middle, that's the midpoint of the segment. Now we have two theorems that talk about perpendicular bisectors. The first one says if a point lies on the perpendicular bisector of a segment. So we have to have a perpendicular bisector, so we need to know these two things are the same, and we know this is a right angle. So if a point lies on there, anywhere on that line, I'm going to put my point right here. Then that point, point P here, is equidistant from the end points of the segment. So your end points are over here and over here. And so what we're saying is we know that this distance is the same as this distance. Those two things are going to be congruent. That's the first theorem. The converse of that theorem is the other thing we learned. And the converse says, let me zoom out just a smidge, that if a point is equidistant from the end points of a segment. So if I have a point up here, point P, and I know that it's the same distance from this end of the segment as it is from this end of the segment, then that point P has to lie on the perpendicular bisector of the segment. So this is going to be congruent to this, and that's going to be a right angle if P is the same distance from those two endpoints. Now an angle bisector is a ray that cuts the angle into two congruent parts. So if we have a point that lies on the perpendicular on the angle bisector, so let's see, here's an angle bisector. That would mean that this angle is congruent to this angle. If we have a point that lies on that, then that point has to be equidistant from the two sides of the angle. So the distance to this side has to be the same as the distance to this side. So those two things would be congruent. When you see this picture drawn, you often see a right angle right here. And the reason for that is that way we know that we're actually measuring the distance from a point to a line. When you've got a line and you're trying to figure out the distance from a point to that line, you don't want to measure the distance over here or over here. You want to measure the distance at a right angle. The converse of that theorem said if a point is equidistant from the two sides of an angle. So if we know that there's a point right here, P, and we know that the distance to this side of the angle is the same as the distance to this side of the angle, then we know that that point P has to lie on the angle bisector. So we would know then that these two angles are the same. And that's what you have when you have an angle bisector and a perpendicular bisector. That's what you know. We're going to go through a few problems and look at what we know and what we don't know. So on this it says, does P lie on the perpendicular bisector of RS? So we know that a point lies on the perpendicular bisector if a point is equidistant from the endpoints. Well, we know that T is equidistant from the endpoints, and T is on the same line that P is on. We know that these two sides are congruent and that we have a right angle, so P is on the perpendicular bisector. Number 8 says, does P lie on the perpendicular bisector of RS? So P is on the same line that T is on, and T is equidistant from R and S, so P is on the perpendicular bisector. Number 9 says, does P lie on the angle bisector? Well, we know that it lies on the angle bisector if it's equidistant from the two sides of the angle, and since it is, we know that it's on the angle bisector. Okay. This one says, does G lie on the perpendicular bisector? Well, we can see that it's perpendicular, and we know that HI and IJ are the same, so it is on the perpendicular bisector. That tells us that G must be equidistant from the endpoints, so we know that 4x plus 5 has to be equal to 2x plus 11, and we can use that to find the value of x.